Okay, good morning and good afternoon to people from all over the globe. We want to introduce you to our live lab sessions that we're going to be having on a monthly basis for NTT. This month, it's the Oracle TimesTen In-memory database. We are very fortunate to have two of very senior Oracle employees, Dario Vega, who is the Oracle product manager, and Olaf van der Geest. I hope I pronounced it properly, Olaf. He's a senior director.
No, you did a very good job, much better than most people. That's great.
Thank you, man. No, I did do Afrikaans as my second language. You know?
I see.
He's a senior director of the TimesTen database management team at Oracle. So people, we are extremely fortunate to have individuals who are sacrificing their time to upskill us as NTT. We are the leading partner in the Oracle space currently, and we're going to capitalize on these events on a monthly basis to make sure that we gain as much as experience as we can from our vendor Oracle. Both Dario and Olaf are on LinkedIn, so you guys can click and connect with them so that you can get all the updates from the Oracle TimesTen products. We're going to have monthly sessions. Next month, we are fortunate to be discussing the tool ZDM, Zero Downtime Migration from on-premise to the cloud. But more on that will be next month. Do look out for the invite. In the chat, there is a survey link. So before you leave, can I please ask, before you leave the session, at the end, can I please ask you complete the survey? That helps us to improve our quality of these sessions. But thank you. I think that's all from me on the formalities. My name is Ahmed Jassat. I'm actually working from South Africa. I'm the operations manager, as well as I'm part of the Oracle ACE program. I'm also part of one of the trainers at NTT. So this will be placed on Workday as well for those colleagues that have missed the session. Dario, thank you very much. Olaf, thank you for your time. Over through to the two of you.
Okay,
we have a healthy audience of around 36 people, which is excellent. So looking forward through to you. I'll be on mute.
It is good. I am sharing. So currently you have a picture of Paris and a picture for Marseille. That is good?
Correct. We can see your screen. Excellent. Thank you very much.
Okay.
People, if you have any questions, put it into the chat. I'll be moderating that. Thank you very much.
Okay, so what we prepare with Ahmed for this session. So instead of talking about feature, instead of talking about function, instead of talking about this, we prepare a demo. It's a demo, it's a kind of tutorial. And the main idea is to see all of our features in action. Of course, I cannot present all the features. So I prepare one of I am considered that will show you what is TimesTen In-memory database, how we can use this database, what are the use cases behind the TimesTen In-memory database. And the best way to do is we will deploy this. For this use case, for this demo, I will use the Kubernetes operator. So we will deploy our database in active passive mode in the Oracle Cloud using the Kubernetes operator. But again, it is just a way to showcase all the features, all the functionalities, and all the use case that we can implement when using a TimesTen In-memory database. So what is the first case for an in-memory database? So in our case, we are talking about a fully relational database, okay? So the first case, what you are expecting from a relational database is create tables, create index, create view, create PL/SQL program. So that is something that you will have with TimesTen. Okay, for example, you have also, it is ACID. It means that we have transactions, so you can create your transaction as in a normal database. in a normal relational database. The only difference is in memory versus what I call disk-based RDBMS, okay? So what we are changing, what is our goal? Our goal is to provide the fast response and the best throughput, okay? So when we are talking about in-memory database, we are talking about very low latency. So instead of talking about milliseconds, we will talk about microseconds. So we are talking about, for example, in order to do a select, we are talking about 1 microseconds in order to do. And when we are talking about throughput, we are talking about high throughput. For example, we are talking about millions of transactions per second, but using only one server, one small server. Okay, so I call this, we call this high performance, high throughput. Okay, so the first thing is what we are obtaining this. So the best is to try to understand what is the difference between a disk-based RDBMS and an in-memory database. Okay, the first is when you design a disk-based RDBMS, you have a buffer pool, and even if you put all your database in a buffer pool, all the design was created thinking that the data is stored in disk. When you are in an in-memory database, all the design was created, the data is received entirely in memory. Okay, so this is why we call this TimesTen In-memory database. So, and in this way, we can have very good performance. And we have two use cases. One is use this database as a classical database, and another use case is use this database as a cache for a subset of an Oracle database, meaning that we will have in in-memory database a subset of an Oracle database of another relational database. So just to start, I want to show you what are an object, what is a database object in TimesTen. Okay, so let me go to the cloud. And the first is what we call a native table. So a native table, you can find all the objects that you have in a relational database. You can have sequence, you can have tables, you can do insert, you can do update, you can do delete, you can do select, you can join tables, you can create reference between tables and things like that. You can create view, you can create materialistic view, you can create package, you can create procedures, and maybe, by the way, you have some packages that are provided by the tool that are very similar as what you have in Oracle database. Okay, why? We are trying to provide a very similar SQL between Oracle TimesTen and Oracle NoSQL database. It is because we have a feature that we call cache groups. Okay, so remember, as I told you here, sorry, we have a feature. We will create a cache for a subset of Oracle database tables. Okay, so just let me show you what exactly means this. Oh, sorry. Okay, so we have what we call a cache group. And we have multiple types of cache group. For example, we have what we call a read-only cache. So as you can see here, I am saying that I will create a cache group that I will call customer orders, and it will base in tables that are in an Oracle database. So in this case, we will have a table in Oracle database called customer in the schema cells, and we have a table called orders in the schema cells. Okay, as you can see here, we are creating a foreign key and reference key between the table sales customer and sales order. What exactly means when we are doing this is when we are creating this cache group, we will have a table called customer in the same schema cells and orders in the same schema, but in TimesTen with that we have the same data that we have in the Oracle database. The interesting thing here, and one of the challenges when you are creating a cache solution is, for example, in this case, I have a table customer, I have a table orders, and I want to be sure when I am loading the data for a record in the customer, I have all the records for the orders, okay? It means when I am loading the data for example, in this case, the primary key is the cost number. When I am reading the data for a customer, I have all the orders for this customer. And when I am doing the refresh, I am doing the refresh of both tables at the same time and not doing one at one time and another at one time, because in this way, I can be sure that when I am querying the data, I am querying a real view of what I have in the Oracle database. And we call this a cache instance. It means that every time that we are reading a cache instance, we are sure that we have all the objects in the cache group, meaning my parent tables and my child tables. We have also the possibility to have what we call a dynamic cache group. It means that we will not load all the data. For example, here I am set here in index in the demo. I will show you an example, and I will say, okay, I will load the data, and then I will refresh the data every 5 seconds or every 5 milliseconds. In this case, when we have a dynamic read-only cache, we will say we will not refresh every, for example, 5 seconds, but we will read when I am reading the data. And that is something that I will show you in the demo. And we have also the possibility to associate this with an edging, what we call an edging, meaning that after a time, we will delete the data that we are not using in the cache already. So what are the use cases here? So for example, when we have a read-only cache, we are expecting to have reference table, SKU definition, price tables, etc. So the tables that we query very frequently, but are not changing very much, okay? And for the dynamic, I think that I provide a very good name, is only customer. So here, for example, we have the customer profile information. We want to have in our cache only the active profiles that we have accessing to our, for example, from our website, that are accessing via TimesTen the data that we have in the cache. So in this case, for example, we are able to have this access. We can pre-populate the cache, but we will only load the data for the customers that are active, okay? And when we merge this with what we call edging, we are able to reduce the footprint that we need to store the data, because remember, we have all the data in memory. And then I will show you some other examples. And the possibility, we have also the possibility to have an write-through cache, meaning that it is not read-only, it is at the table. So when we are updating the data in TimesTen, we will automatically update the data in Oracle database. As you can see here, we have two different ways, asynchronous. Most of the time, our customers are using asynchronous. So imagine that, for example, you have multiple stores, and you have in your store, you have a TimesTen database. You can, for example, create a new order locally. And then when the database, for example, you can, sometimes the database is inaccessible because we have the Oracle database, for example, in one data center or in the cloud. So we are saying, okay, I will commit my transaction, and then when the connection will be established again, I will send the data to the Oracle database, okay? But I can have a portion of my data in my TimesTen, and then I can have all the data in the Oracle database, okay? Again, I will show you an example that I think in our demo, it will be clear. Here, the use cases are, for example, you have events in your, for example, phone billing, smart meter scan, RFID scans. And in this case, you want that the real-time events happen, record them and insert into the TimesTen, do some aggregation, do some analysis, and then push them to the Oracle database. If, for example, if you want to do more sophisticated analytics, and we call this offload the data, because in fact we will have in the TimesTen only the active records, and we will have in the database all the historical data. Okay, so that is about the use case. That is about the object that we have in the data in the TimesTen database. So that is an in-memory database. That is a small introduction. So now I will go on how to install an Oracle TimesTen database. So we will have two use cases. Of course, I will not execute the lab one, that it is creating a Kubernetes cluster and what we call installing the Kubernetes operator. The first thing that I will do with you is deploy an active STAM database pair. So meaning that I will install an Oracle TimesTen in-memory database with a solution with an active and a standby database. So if something's happened in my active, the standby will become if something happens in my standby, in my active, the standby will be redirected to be the active, and we will create a new data guard in order to have our high availability. So just let me start. So we will create, in order to do this, we will use Kubernetes. If you are not comfortable with Kubernetes, we can say we will have a cluster and what we call pods. You can say, okay, that is a VM. Okay, so we will create some VMs and we will deploy the software inside, and we will start a database inside of each pod. So just let me start. I will do some configuration. Of the first thing that on all databases, we will create our initialization file. So in this case, the only thing that I will say is the database character set is AL32 UTF-8. Okay, and then I will provide all the default when I am creating my database. Okay, so that is the first thing. So I have the operator, and I will say to the operator, here is the configuration. Please deploy TimesTen database in active passive mode using the following information. Okay, so then I will move to my schema. So I will say I will initialize with an schema. So again, here I will simply create a table that I will call in the schema sample user. I will create a sequence that I call S, and I will create my first table that I will call employee. Okay, a vacant ID, a name, and a primary key. And then I will create an object that we call a config map. That is a Kubernetes object. You can imagine it is something that I will mount in my VM. In my case, we talk about Kubernetes objects in my pod. So if you look what is inside, so we are just saying I have a file called db.ini with this information. I will have a file called schema SQL with this information. Then I will create a secret, and that is the same thing, but it is another way to store data, because here I will store sensitive information. Okay. So it is very simple. When you are creating a timestamp database, you can say, what does that mean? And in this case, I will call that mean sample user with a password that I call sample password. Okay, very simple. And then again, I will create a specific object in Kubernetes that we call a secret. Okay, and if I describe my secret, I am saying that I have a file called admin user, but it is a secret, so I cannot see the information that I have inside this file. Okay, if you remember here, I am able to read what is the information that I have here. And then we will deploy our our TimesTen configuration. And in order to do, we will create a file that we call a YAML file. And in this file, I will describe how I want to create my database. Okay, so I am saying that I will create a TimesTen classic. Remember, we have the possibility to have two ways. So currently, I will use only TimesTen. And I am saying, okay, I will store the data. So that is what we call, if you remember, I need to store the data in something that is persistent. So here I am saying the size of this storage is 50 gigabytes. And I will say I will use this image that it is in a container registry, or we have the software, the TimesTen software. And then I will say, okay, you will use this configuration file and this secret in order to deploy our database with the active database. That's, as you can see here, I create. And then we can monitor, because it will do all that we need in order to create a database. So I just want to show you what exactly means this. So the first thing is we will ask what are our TimesTen classic objects, and we will have one that I call my TimesTen DB. And as you can see here, the state, it is in initializing. We have multiple states depending on the status of our database. And then I will describe, and we will see what's happening. As you can see here, they are asking for a database CPU. In my case, I am not saying what are the limits, so we don't have limits. I am using this secret. In my case, I don't have the Prometheus operator, but if I have the Prometheus operator, it means that all the monitoring of my TimesTen database will send that this Prometheus operator, and you can monitor all the events, all the statistics that we have in our TimesTen database, okay? And as you can see here, if we continue, you will see that it is deploying all the things that we need. So for example, here I am deploying the agent, I am loading the database, I am the replication agent. That is the agent that we are using to do the standby. So here we are deploying this. And as you can see here, we are deploying two pods. One is the active, and the second one will be the standby. Okay. Again, we are populating everything. Currently, we have the replication state at idle. And it seems that everything is ready. So we will confirm this. So we will execute again this command. And as you can see here, we have normal, and it is saying that the current pod is my TimesTen DB. Okay, so just let me continue using Kubernetes. So that is not really important. That is for people knowing Kubernetes. We are saying all the objects that were created. We are creating what we call an stateful set. We are creating a service. We are creating pods. We are creating persistent volumes. So as you can see here, I have two pods. So we can consider that we have two VMs, and it is running three containers, meaning that we have three processes that are running inside this VM. Okay, now let me continue. So the first thing is I will verify the connection to the active database. So again, that is a command to go inside this pod. And as you can see here, I am just requiring a batch. Okay. Remember, I am choosing the active. The active is TimesTen DB. Now we are inside, so we can execute some commands. So we will execute this command that we call tte-SQL. So that is to show we are doing the connection to the database. and we will execute some commands. So instead, I will change the user to say that I am connecting using simple user. If you remember, that is the parameter that we add in the db.ini. Okay, so we have some other parameters. And when I call what are the tables, but I have a table. That is the table that we created. We have to create a table called emp. And then, of course, we can do an insert, we can do an update, and we can do a select. So we have very similar concepts. So we have an user, you can access to the tables of the other user if you have the privilege. And here I am saying that I am doing this specific table. If I am not providing the specific schema, it is the current schema. The current schema is sample user. And I am doing a select. So I insert Dario Vega. So that is a mistake. Then I change to Dario Vega. And when I do a select start from table, I have Dario Vega. Okay. When we are deploying an application, why we are using this is because if you remember, our first challenge is performance, is low latency, it's high throughput. So what we are trying to do is we will use something that we call a direct connection. In this case, we are doing a direct connection, and I will go a little bit. In fact, we are accessing directly the memory, and we are not doing any IPC call in order to copy the data. In this way, we can obtain the best performance for our application, the best latency, the best throughput. Okay, this is why it is really interesting to deploy using Kubernetes, because currently our customers are deploying the application where in Kubernetes. Or we can say that most of the time we are deploying Oracle TimesTen In-memory database as an embedded database, so near to the application server. And the best is if we can have the application server and the database in the same server, in my case, in the same pod. So just let me try to do a failover and recover of the timestamp. So as you can see here, I will delete my pod. Just let me do exit. So I am killing the pod. You can think this. I am killing my active database. So now it is deleted. As you can see here, the operator realized that it was deleted, so it is initiating again this pod, so creating again this VM. Okay, so just let me provide some commands. Oh, it is finished. Here, just for information, it takes 30 seconds to the operator is monitoring the database, and it is taking 30 seconds in order to identify that something is wrong. So currently, I am waiting for these 30 seconds. Let me see what's happened. Okay, so currently, oh, it is realized that it is not more any here. Okay, so now it is doing the modification. So as you can see here, it is saying that the standby is down. So it is activating everything. So we have a different state. And here we can monitor what is happening, okay? Another way to do this is look for the events. And as you can see here, the operator is doing the failover, okay? Another way to install TimesTen Classic is using Oracle Closeware. Okay, it is when we are, instead of using Kubernetes, we are using VM, and you are installing Oracle Clusterware, and the Oracle Clusterware is monitoring this and is doing the change between the active database and the stand database. So here, I think that is a better solution because we are in Kubernetes. So instead of using an external tool, we are using what we call the operator that is in charge of this. So it seems that everything is ready. So now if we go to describe the TimesTen, sorry, not describe, but get, we have the output. So everything is normal again. Okay. So we can say that we did our first, we create our first TimesTen. We connect to this database. We did some actions, and then we simulate and handle failover and recover in the TimesTen Classic. Okay. As you can see here, using the Kubernetes operator is very simple because he is in charge to monitor the status of the database. Okay. As I told you, there is another possibility to do the connection. One is the direct access, and the other one is what we call, we will deploy a client, and we will use a connection to this using using the network. Okay, so in order to do this, I will simulate this by creating what we call a client pod. Okay, so again, I need to create a configuration file to describe what I want to deploy. So that is a Kubernetes configuration file, and I will copy again. This is the most simple application that I never create. So because in this case, my application is just doing sleep. Okay, the main idea is that we will connect inside to see what we are deploying. Okay, so just let me execute this. And then we will deploy. I will see. So now instead of connecting to my server, I will call this a server, but it is a pod. Instead to connect it to my database, I will connect to the client. Okay. And I will configure my client. Okay. So in order to do this, we have this file, sysodbc.init, meaning that we will use the ODBC driver for do this connection. I will go to the end, and I will describe how to connect to my TimesTen database. Very simple. I am saying that I am connecting to my TimesTen. That is the address of my first pod. So my stem database 0, my TimesTen default, and that is the address of the second pod. Okay, so that is we can say that is the address of a VM, that is the address of another VM. And now I will use this configuration file in order to do the connection because I am not doing the direct connection. So in order to do this, I will use another tool that we call the TimesTen SQL, but client server. So we are doing the connection. If I execute tables, I have the 10 table. If I execute select star from my table, but I will have the data that I put in my table. Now we will deploy the TimesTen in-memory database as a cache. So the first thing that we need to do is we need to have an Oracle database because we will have the data in Oracle database, and we will create a cache group in Oracle TimesTen. I will create a read-only, and I will create an write-through cache. So one is at the table, the other is only. So just let me do this. So in order to do this, the first thing that I need to go is to create a specific user that we will call the cache administrator. administrator. Okay, the main idea is we need to have a user that is in charge to do all the synchronization between the tables in Oracle and the tables in Oracle TimesTen via the cache group. It means that when I am modifying in Oracle database, if it is a read cache, I need to put the data to the Oracle TimesTen. If I'm modifying the data in Oracle TimesTen, I need to update the data in the Oracle database. So in order to do this, I will create a user in my database. So just for information, I have here a database. That is the descriptor in order to do the connection. And if you go here in my environment, I prepare multiple databases. So for example, I have an autonomous database. This database is a cache. I can have also a database that we call Oracle Database Cloud Service. So in this case, I have this database. I can have a database on-premise. I can have a database in another cloud provider. I can have a database that is deployed in Kubernetes using the database operator. I don't know if you are aware that we have also an Oracle database operator. Okay, so in this case, for my test, I will use the database and I will use my autonomous database. So I will do the connection. I will restore. And I will go to my instruction. It is autonomous. So instead of using SAST DBA, I will use the user admin. I will look for my password that is confidential. Okay, and then I will create this user that I will call cache user 2. And then I will run a script that are providing all the privilege needs to this cache user in order to manage the cache group. As you can see here, I am executing this script and saying that it is for cache user 2. Okay, so everything is done, seems good. And now that is when I am doing the cache for an application, I need to create first the Oracle database that I will cache in my TimesTen database. So currently, normally, it is the application that you are already running in Oracle database. What's happening here? Second. There's an error here. Okay, so I create my user. That is just an application user. Just remember the name is OraTT. And I will create two tables. One that I will use to showcase the read-only cache and another one to showcase the write cache. Okay, so I will create two tables here. I will disconnect because that is really strange. I don't know what I lost. The feedback. Okay, and I will insert some data. Okay, and I need to provide the privilege to my cache user to manage my table. So I just want to show you what are the data that we have in the Oracle database. So for read, oh, sorry. For read, we have a simple table with a key and a string, and the value is one hello world. Okay. And for the second one, we have a similar table, but we have 100 times 10, 101 cache. So try to keep in mind those values: 1 to hello world, 100 times 10, 101 cache. And now we will deploy another times 10 database, but in this case, in order to create the cache group. Okay, so I will do the same thing that we did for the previous one. So the first difference is, I would say, I will have an Oracle Net service name. It is cache high, meaning I will connect to, when I will do my cache group, I will connect to this database that I call cache high. Then I will create a specific user. It is not the admin user, it is the cache user. It is the So I will create with the same name that I create in Oracle database. So the same name, cache user 2, that is the password in Oracle database. That is the password that I will create in Oracle TimesTen, just to show that we can have something different. I will create the same table just to show you that we can have both at the same time. We can have cache group and we can have native tables. And I will create my cache groups. Currently, I am not creating. I am creating the configuration to say to the Kubernetes operator to create those objects. So as you can see here, I am simply creating an asynchronous write-through cache. Then I will explain you what is happening when we have the dynamic. I will create a read-only cache that I will call read cache based on this table. Okay, and as you can see here, I will execute this command to load all the data that I have in the Oracle database table for this table, read tab. Okay, and for this one, I decide to have an empty cache. Okay, remember, this is one of my use cases. And we will execute the same commands. Error here. I'm not executing in a good place. It is created. It is already created. So I will go directly here. So as you can see here, the only difference is that I have another config map with the TNS information. So that is my TNS name.ora in order to do the connection to the Oracle database. And then I will create, and I will do exactly the same steps. Now we are deploying. And we will see what's happened. So it starts to create the new TimesTen database that I call CacheDB. And again, we will create an active standby configuration, but inside we will create two cache groups. And for one of those cache groups, I will load the information from the Oracle database. It is the problem with the live demo. You need to wait. So it is initializing. And remember here, you can have multiple TimesTen database. In this case, multiple TimesTen, and each database is an active standby configuration. Still initializing. We are doing the replication. So now it is ready. So now we will do the same thing. We will connect to my pod. In this case, I will connect to CacheDB.
Can you share your screen? Sorry, not sharing your screen.
It is not sharing. Okay.
No.
Then I don't know what was happening. It's okay now.
Perfect. Yes.
Okay. Sorry, I don't know what was happening. Okay. So now I will connect again. And instead of ask for my table, this time I will ask for, wow, what I did. Because I am not in time, I think that I forgot something, and that's not good. Okay, so I will continue with the instructions. So as you can see here, we will deploy our read cache, okay? And in this case, we have a read-only. We have auto-refresh incremental every 5 seconds. And then we will have our write cache, and it is asynchronous write output, and we have an edging LRU, okay? The interesting thing is when you will execute select star from this table, you will have the same information that we have in the database. One hello, two war, if you remember. Now, if you go to the database, to the SQL database, and you execute, for example, insert into Oracle read table, for example, the value 3 and welcome, you delete the value for 2, you update to say that the value for 1, it is not anymore hello, but hi, and you commit and you execute, you will have 1 hi, 3 welcome. If you go again to the TTA in the TimesTen utilities and you execute the same select, you will have sorry, we will here you will have, that is a problem in copy paste, you will have hi, welcome. Okay. Then you will go to this table or a write table, and here I will provide you some explanation. So what I am expecting, sorry for because here I forgot something because I think that I am running out of the time, so I forgot to execute something. When you are using this is the table. If you do a select star from Oracle TT write table in times 10, it will be empty. Why? Because if you remember, when we create the write cache, we didn't execute the load command, meaning that we are saying we will start with an empty cache. When we do this select start from pk equal 100, we will load the first value for this table from the cache. So this is why we are talking that is a dynamic cache. If you insert a new row, you will see that we will put the same row in the Oracle database. If you delete this row, because here you have the primary key, the first thing that we will do is we will read the data. Now it is in our TimesTen database, and now we will delete, so we will propagate this delete to the Oracle database. Then we will update in TimesTen, and then I will do a select, and then I will connect to the Oracle database, and I will have the select in the same select in both tables. So meaning that when you have a write cache, you are supposed to update only the Oracle TimesTen database. You are not supposed to update the Oracle database. You can have more data in the Oracle database that you have in the Oracle TimesTen database, because in one you are in memory, and the second one you have the possibility to store your historical data. Okay. The other thing is, by doing the dynamic, you can say, okay, I have only the data in my TimesTen database, only the active data. Or if you remember, when we are creating, I just want to put this example again here. We have the possibility to have an aging based on an LRU system, but we have also the possibility to have an aging based on a date. Okay, so here, for example, I am saying I will keep the data for 45 days, and every 60 minutes I will delete the data from the TimesTen database, but not from the Oracle database. So that is the difference. So I am adding in my TimesTen because it is in memory, but I am keeping the data in the Oracle database for analysis. I think that is all for my side, Ahmed. I don't know if there are questions. I don't know if it is our use case are clear. As you can see here, we can use Oracle TimesTen in-memory database like a full, if I want to summarize, I just want to go to my introduction, as a full in-memory relational database with SQL relational ACID compliant database, or I can use this tool in order to cache for performance a subset of the Oracle database. Again, there is a lot of possibilities. I can have my database, for example, on-premise and my cache on the cloud. I can have my database on-premise and my cache, my database on the cloud and my cache on-premise. I can have my database in Oracle, for example, cloud infrastructure, and I can have my TimesTen cache in Azure or in AWS. And I can have multiple possibilities to deploy this. Another way here is I am saying you can create one or more in-memory SQL. It means that you can have, for example, 1, 2, 3, 4, 5 TimesTen. You can create 4 TimesTen cache, and they are all sending the data to the same Oracle database. So, for example, from application point of view, you can do a partitioning. For example, you can have a TimesTen database in South Africa. You can have a TimesTen database in Europe. You can have a TimesTen database US, but you can have your central database, I don't know, maybe in Namibia, for example. That is the main idea. That is why it is an interesting solution for cache, but that is also an interesting solution for people looking for performance, for high availability, for low latency when using an in-memory database. The good thing, it is not an in-memory, it is a full relational in-memory database.
Thank you very much for that excellent discussion, demonstration. We had a full house here, over 44 people. Are there any questions? We have our last 4 minutes left before our guests leave us. Okay, it doesn't look like there's any questions. If there is, just put it into the chat. Can I please ask that everyone please fill out the survey at the bottom? There's a link on the chat there. So we're about 35 people here. So please, take 2 minutes just to click on the survey in the chat and complete the survey on the presentation. We will be having next month another presentation. That one will be with ZDM, Zero Downtime Migration. We want to thank our 2 guests. Dario, thank you very much for sacrificing your time to demonstrate to us. And of course, Olaf for coming online as well. Thank you all.
It is not a sacrifice, it is a pleasure.
Thank you, Dario. Appreciate it. Thank you all. Bye-bye.
Bye-bye.
Bye.